Okay, I'd like to just take you through an example to show you the difference between a linear relationship and a nonlinear relationship. And first, we'll just go through what linear versus nonlinear means. So, like the name implies, if something is a linear relationship, it makes a line when you graph it, and it's got a constant rate of change. If something's nonlinear, then it doesn't make a line when you graph it, and in this case, the rate of change would not be constant. So I'm going to show you these two ideas using some examples. So first of all, we'll look at a linear relationship. So in this situation, we have Cynthia who is opening a bank account and she's got $500 in it to begin with. And she's going to take out $50 a month, and she doesn't put any money back into it. So she's just constantly taking $50 out each month. So, like as we looked at last week, we can look at this situation and we can pick off what is the initial value and what is the rate of change. So in this case, the initial value is the amount that she has at the beginning. She starts with 500. So she's got $500 initially, and then her rate of change is going to be minus $50 a month because she's taking out $50 every month, so that it's going down every month. So we've got to make sure we put that negative in there. Okay. So then we want to just kind of look at it from the different representations, because remember, we always want to be able to visualize relationships in words, in tables, in graphs, and then eventually, which we'll talk about tomorrow, in using equations. So what I've done is I've created a table of values to show this relationship. So I started with my independent variable, which is the number of months. That's the variable that I control. And what depends on that, or my dependent variable, is my balance. So you'll notice in the table of values, I always put the independent variable first as my X column, and my dependent variable second, and I call that my Y column. The X always comes first and the Y always comes second, just like it does in the alphabet. So the independent variable X, the dependent variable Y. The other thing I did in my table of values is I started at 0. Whenever I can, I always start my table of values at 0 so that I can see what is the initial value, because I want to make sure it's a key piece of information, and I also want to make sure that I'm able to put that onto my graph. So I start at month 0, and then I put 1, 2, 3, 4, 5 for this situation. And I know from what the example tells me that the initial value at month 0 was going to be 500. So my dependent variable, my balance at month 0 is 500. There's my initial value in the table of values. And then from there, I can logically just take $50 away every month. So at the end of month 1, she's got $450. At the end of month 2, she's got $400. Month 3, $350. Month 4, $300. Month 5, $250. So we kind of did this in our head. We took 50 away each time, but we can formalize this a little bit. Every time when we look at how a dependent variable is changing as our independent variable goes up by the same amount, so this is going up by 1 every single time, I can see that the dependent variable is going down by 50. So if I take 450 and I subtract 500, I know that that has gone down 50, so I put minus 50. If I take my 400 and I subtract the number above it, which is 450, I also get negative 50. 350 minus 400 is negative 50, and so on. And I call these numbers the negative 50, which is basically my rate of change. I call that the first differences, because it's the difference between the second value and the first value, and how I go from the first value to the second value each time. Okay, so if I look at these first differences in this example, the first differences are all the same. They're all minus 50. Every month that we increase, the balance is going down $50. So because the first differences are the same, we know that the rate of change is going to be constant. Every time I take my rise over my run here, I'm always going to get minus 50, okay? And that is an indication that it's a linear relationship, because as I can see, if I take this data here and I plot it onto a graph, and you'll notice here, just to keep things straight, my X, or my independent variable, always goes on the horizontal axis. So the first column of the table of values, which is your independent variable, is always labeled on the bottom or the horizontal axis of your graph. That's your x-axis. the balance, or my dependent variable, what was my y in my table of values, always is my y-axis on our graph. So I put the balance on there. You'll notice too that I went up by a constant amount when I was coming up with my scale. So here I went up by 1, 2, 3, 4, 5, and so on. And here I went up by 50s, 50, 100, 150, 200, 250, 300, and so on. So I kept that scale almost like skip counting when I was creating my scale to make sure that I've got my scale done properly. And when I take these values and I plot them, so I plotted on the initial values 0 and 500, 1 and 450, 2 and 400, and so on. When I take those values, I can see that I've got a linear relationship. It looks like a line, so it's linear. Okay? So this is an example of a linear relationship. It's the first differences are the same, which we can tell from the table of values, and the graph looks like a line. Okay? So in a second example, I'm going to show you kind of a similar situation, but this time it's going to be a non-linear relationship. Okay? So in this example, we've got Caleb, and he's starting with no money in his bank account, but he's going to start saving some money. So at the end of month 1, he's going to put $20 into his account. And after that, he's going to double the amount that he puts in from the month before. And we're also going to assume that he doesn't take any money out either. Okay, so I'm going to pick off the key information. So the initial value is how much he starts with. So he starts with no money in his account, so that's going to be 0. But when I look at the rate of change this time, it's a little bit harder to define because he's going to put $20 in after the first month, and then he's going to start doubling that amount. So it changes every month. It's not a constant rate of change this time. Okay, and we'll see how that plays out when we start looking at the table of values in the graph. So again, table of values, I'm going to start with my independent variable, my x value in my first column, my dependent variable, my y value in my second column. I'm going to start at 0 because I always want to see what my initial value is. And I know that when he first opens the account, before any months go by, he's got $0. So the initial value is going to be 0, 0. And I'm going to use this information up here to actually do my first differences. And I'm going to use my first differences kind of in the opposite way to help me figure out what my balance is. So I know that after the first month, the first difference is going to increase by $20. So I go from 0 to 20. And then for my second month, I'm going to double the amount that he put in. That he's going to double the amount that he put in the month before. So if he put in 20 the month before, he's going to put in 40 this time. So I'm going to do 40 plus 20, which gives me 60 for my new balance. And again, I know that's going to double. So it's going to double to 80. 60 plus 80 is 140. Again, it's going to double to 160. 140 plus 160 is 300. And then 160 doubles to give me 320. 320 plus 300 is 620. So you'll notice here, I've got my table of values. My first differences, unlike the first example, are changing every time. They're not the same number every time. So I can tell just by looking at this table of values that it's not going to be a linear relationship when I graph it. It's not going to be a line because the first differences are constantly changing. Okay? Their rate of change is not constant. And I can verify that just by putting it on the graph. So again, my x value, my number of months always goes on my x-axis. So my number of months is here. My balance, my y's, my dependent variable is always going to go on my y-axis. So I've got my balance here. And when I take these points and I plot them, I get a curved relationship. So I know that by looking at this, because it doesn't make a straight line, it's another proof that this is not a linear relationship. Okay, so just to summarize, if I go out here, I would like you to be able to determine whether or not something's a linear and non-linear relationship. There's a couple different ways you can do that. The graph is probably the easiest way. So you can look at the graph. If it makes a line, it's linear. If it doesn't make a line, if it makes some kind of curve or some kind of alternating pattern, then we know it's not linear. From a table of values, we look at the first differences of the dependent variable. If the first differences are constant, then we know that when we graph it, it's going to be a line, so it's going to be linear. And if the first differences are not constant, if they're not the same every time, we know by looking at the graph that it's not going to be linear. So we can tell just by looking at the first differences of a table of values whether or not a relationship is linear or nonlinear.